Hello, my name is Delali Sebo and welcome to my final presentation for the Database Systems course. My work is focused on developing a database to address the needs of a medical laboratory called LEDing. This presentation will cover the entire process from the background to the queries. For a bit of background, LEDing Medical Laboratory is a clinical lab which provides high-quality PCR and antigen tests against the coronavirus disease. For this project, there are 10 entities in all, with 6 of them being strong and 4 of them being weak. For each of these entities, here are their non-key attributes. Up next, we have the EER diagram. We have our 6 strong entities with their primary keys displayed. From here, we can see that a customer makes a reservation. A payment validates that reservation. The reservation has a test. The test happens in a test hall. The test has a result, which is sent to the customer. The customer can also make a complaint. An employee attends to a customer, an employee uses equipment, suppliers provide equipment. The various multiplicities are displayed on the screen. Due to the many-to-many relationship between customer and employee and equipment, equipment and supply, customer and complaint, there were decompositions leading to customer-employee, employee-equipment, equipment supplier, and customer complaints. Also, there are 2 specializations of the general class of employees with an optional or relationship, which means that an employee can either be a medical officer or an intern or none of the 2. We'll now move on to the logical table derivation process. For the logical table derivation, bold and underline refers to a primary key, and bold and italicized refers to a foreign key. Firstly, a table was created for each strong and each weak entity, with the primary keys of the strong entities defined and those of the weak entities undefined. For the one-to-many relationship between test and customer and test hall, the many side had mandatory participation. Hence, the primary keys of the whole table and the customer table were posted into the test table as foreign keys. In the customer table, there's an attribute for customer type. In the customer table, there's an attribute for customer type. So to avoid repetition and for the purposes of normalization, the customer type table was created and the primary key of that was posted into the customer table as a foreign key. The same goes for equipment, because some equipments in the laboratory have different classes. 2 different tables were created for the specializations of employee, with each of them having the primary key of the employee table as foreign keys. Reservation has a one-to-many relationship with test, payment, and customer. And all these instances have the many side having a mandatory participation. So the primary keys of test, customer, and payments were posted into the reservation table as foreign keys. The customer complaint table is a result of the decomposition between customer and complaint. Hence, the customer complaint table has both the primary keys of customer and complaint in it as foreign keys. Because of the one-to-many relationship with mandatory participation again, payments has customer ID in it as foreign key. The results table has customer ID and test ID as foreign keys for the same reasons. Employee, equipment, and equipment supply are results of decomposition and hence have the primary keys of their parent table as foreign keys. We'll then move on to the SQL. So a number of constraints were used in writing this code. There's not null, there's unique, and there are some check constraints as well, as you can see. And due to the frequency with which I'll be accessing some columns within the tables, a number of indexes were created. For example, the test date attributes in the results table, the vaccination status in the customer table, and the complaint ID and customer ID in the customer complaint table, as well as the amounts paid attributes in the payment table. We'll now move on to queries. For the first query, the first functionality says provide information on the number of antigen and PCR tests conducted within the year. From the output, so for the first query, we are counting the number of tests for the year 2022, and we are grouping by the types of tests. So from the output, we can see that in the year 2022, PCR test was ordered 4 times and antigen test was ordered 9 times. So the second functionality of the database says provide information on the number of positive and negative COVID cases and their vaccination statuses to the Ministry of Health statistician for national health purposes. So we are selecting the vaccination status and contrasting it with the COVID test status using an inner join on the customer IDs. The output shows that 3 people who tested positive have been vaccinated and 4 of those who tested positive have not been vaccinated. We also see that of those who tested negative, 4 of them have been vaccinated and 2 of them have not been vaccinated. The third functionality of the database was to provide information on the type of clients who generates the highest income for lending for marketing purposes. So the sum of amounts paid is selected and the grouping is done to show the ranking of the types of customers and the income they brought in the year 2022. So from the output, we can see that the corporate customers brought in the most revenue in the year 2022, and therefore they should be targeted by the marketing team. The next functionality of the database is to track specific employees who worked on a certain equipment with a certain month, within a certain month for maintenance and security purposes. So we pull up, using a subquery and a join, we pull up the employee who worked on an electron microscope in the 6th year of the month of, in the 6th month of the year 2022, sorry. The next functionality of the database was to provide information on the most frequent type of complaints that customers lodged for a particular year's quarter to enhance quality customer service for the coming months. So this query pulls up the complaints that have been lodged in the 2nd quarter of the year, with the number of times such complaints were lodged for customer care improvements. So as we can see from the output, in the 2nd quarter of 2022, the most lodged type of complaints were complaints about refund, payment refund, and complaints about the tests. The final query is to check the number of customers who returned in 2022. Then the final functionality was to provide information on returning customers to aid analysis on customer retention within the year 2022. And so from the output, we can see that these customers, the various customers returned twice within the year. This brings us to the end of my presentation. Thank you very much.